here is going to be radical expressions, and we're going to cover a couple different things today. One is just being able to simplify a radical, not by just certainly, and I know you guys have been used to maybe just finding the square root of a number. Okay, so we're not going to be simplifying that way. We're going to be simplifying by breaking what we call the radicand into factors. So let's just go over the parts to a radical first. Inside here, and I'm just going to call it, let's just put a number here. Let's say you have 35. It really doesn't matter what the number is. That number inside, and it could also have a variable attached to it. Okay, it really doesn't matter, but that's called the radicand. Okay, the bracket itself, or the house, is called your radical. And there's an invisible number inside of here, which is a 2 right now. That is called your index. So sometimes you will see the number inside, because if the number is higher than 2, you might see like the cube root of something. Okay, like the cube root of 8. So the index is very important because it tells you, especially if you're doing, like, let's say a perfect square, and it's asking you what same two factors, because there's an invisible 2 here, what same two factors can you multiply together to get 100, and that's why we say the answer is 10. And technically it's positive and negative 10. Okay. We're only going to be dealing with, of course, the positive roots for right now. But the index says what same two factors can you multiply together to get the radicand, which means if the index changes to a 3, it's asking what same 3 numbers can you multiply together to get 8, and the answer is 2. Okay, so that's why the index is important. You might also see an index of 4. So that's asking you what same 4 numbers can you multiply together to get 16, and the answer is 2. Okay, so you do want to know the parts of a radical. What we're going to do now is go over how you break down the radicand into factors. So let's just take a number like 28. So I'm not asking you to find the square root of 28 and give me some decimal number. So and this kind of helps with your whole multiplication facts here. What two factors you can multiply together to get 28, but one factor is a perfect square. So just think about that. What times what gives you 28, where one of the factors is a perfect square? Yes. All right, very good. 4 times 7. Now, of course, 14 times 2 will give you 28, but neither number is a perfect square. So now that you have taken the radicand, 28, you've broken it down to 4 times 7, you take the square root of the 4 out. So anything that's a perfect square comes outside of the radical. So the square root of 4 is 2, and you end up with 2 rad 7. All right, so let's take an example with exponents. So how do you know if an exponent is a perfect square? Because you're going to have some problems where you might have, let's say, 64. Let's make it a perfect square this time. But then you have some variables here. So how do you know if an exponent is perfect? There's a different rule for exponents. So here we go with our exponent rules again. In order for an exponent to be a perfect square, it has to be an even number. It has to be a multiple of 2. Okay, just like if it's a perfect cube, it would have to be a multiple of 3. Okay, so perfect squares for exponents. Okay, Okay, must be a multiple of 2. Okay, and perfect cubes for exponents must be a multiple of 3. Okay, so there's where that index plays a role as well again, because there's an invisible 2 here. That's why we call it a square. So if you have 64, a to the 5th, b to the 4th, well, I do know that 64 is already perfect. So I'm going to take that outside of the radical. I know b to the 4th is perfect, so I'm going to take that outside the radical. Now, when I take the square root of b to the 4th, I divide by the index. And the index here is what? 2. So what's 4 divided by 2? 2. Okay, so that's why that index is important. So if I were doing multiples of 3, then I would divide by 3 when I take it out. So now I'm left with this a to the 5th, but I can simply break that into factors just like I did the numbers. So like I broke down the 28 a few minutes ago to 7 times 4. I'm going to break down this to a to the 4th times a. Same thing. So you could also break down your exponents into factors. So all you would do is go, when you have an odd number, go back one number, gives you 4, 4 and 1 gives you 5. Okay, that's our product rule. When you add these together, you still get a to the 5th. Now I can take this out because now it's considered a perfect square. That's what I want it to happen. So when I divide that by the index, which is 2, I'm going to have 8a squared, b squared, rad a. So whatever's left you cannot take out, stays under the radical. Okay, that's not a perfect square. A to the 1st power is not perfect. Okay. All right, we're going to do one more, and then I'm going to actually show you how your calculator can take the radicand and at least get that answer for you, because it's kind of neat to see that on the calculator. All right, so let's just take a look at this. We have 72x to the 7th, y to the 3rd. Now, 72 is not a perfect square, but I can certainly find a perfect square in 72 as a factor. And this one you have to be very careful of, because there are actually a couple of factors that are perfect in 72. So you want the largest perfect square in 72. The largest perfect square in 72 is actually 36. Is that true? Okay, all right. So I'm going to break it right down right now to 36 times 2. Then I'm going to break down my exponent to 6 and 1. Okay, because that gives me 7. Then I'm going to break down the y to 2 and 1. Okay, so everything now has factors. Everything that's perfect, I'm going to take it outside of the radical. So obviously 36 is perfect. I'm going to take it out. X to the 6 is perfect. How do I know x to the 6 is a perfect exponent? Because it's a multiple of what? 2. Or you can just say it's even. Okay, it's the same thing. Okay, anything that's a multiple of 2 has to be an even number, correct? So then I'm going to also take this out. So I divide 2 divided by 2. Let me write this as x to the 3rd first. And then 2 divided by 2 will give me y to the 1st when I take it out. Okay, so whatever's left, which is this, this, and this, stays under the radical. All right, so what we're going to do is go to our calculators. And we're going to hit the y equals key. Okay. Let me clear that out. And we're going to put in 72 divided by x squared. So since we are doing the square root, we divide it by x squared. If we were doing cube root, what do you think we would divide it by? X cubed. Okay, so since we're dealing with the square root symbol, we're going to divide it by x squared. So then you're going to go to your table, hit second graph. Now, what you're looking for in the table, so let me show you what you're looking for. You're looking in the Y column, and you're looking for in this column over here, okay? So you want to be in this column. You're looking in the Y column, and you're looking for the last whole number in the Y column. The last whole number in the Y column. Because after that, everything will be decimals. So see right here where it's a 2, okay? Everything after that in the Y column, if you keep scrolling down, you will see they're all decimals. That's how you know you have arrived at the right answer, okay? So let's go back up. Okay, so we got 6 rad 2 a few minutes ago. I think I went a little bit too far. Right here, this was our answer. So you can't stop it here. Here's also a whole number of 8. That is not a simplest form. You know it's in simplest form because after this 2 in the Y column, everything repeats decimals. Okay, so you could actually do that part on your calculator. All right, so let's go to page 16. Page 3 in your packet, and the first question is rad 16. And I just want you to put this in because I know everyone knows that anything 16 is a perfect square, and we already know the answer is 4, but I want you to see what it looks like when you do it on the Y equals key. So if you're on page 3, the first problem says rad 16. We know the answer is 4. I want you to see what it looks like on the calculator. So put in 16 divided by x squared. Okay, so when you go to the table now, you know it's a perfect square when, again, here's a 1. That's the last whole number that's in the Y column. It's going to say 1. That means it's a perfect square. Now, you don't write 4 rad 1. You just simply write 4 because it's a perfect square. But I wanted you to see that this is how you know it's perfect because there's going to be a 1. Right? So on your packets, just go ahead and put in 4 for the first one. And then we've already actually done 28 earlier. Okay, so we had broken that down. We had actually done this one by hand, and we said the answer was 2 rad 7. So now let's do this one on the calculator. So go ahead and hit your Y equals key and put in 96 divided by x squared. So when you go to the table, second graph, okay, so now I see a 6 here in the Y column. Is that the last whole number? If that's the last whole number and everything after that repeats as decimals, then there's your answer for rad 6. All right, that's going to have to share somebody. Now this is already simplified. You can't simplify that anymore. Okay. Let's go down to where we have some variables in the problems as well. So we'll do a couple of these. So if you want to hit the Y equals key, I'm going to actually do this one by hand. I know 45 has a perfect square of 9 in it. So that's going to give me 3 rad 5. Okay. Now, if you want the calculator to do it for you, you will hit your y equals key and put in 45 divided by x squared, and in the y column you should see a 5, and in the x column you should see a 3. Now, let's take care of the variables. Okay. X to the first power is not going to change because it's not an even number, so that x will stay under the radical. Y to the second is a perfect exponent because it's even, so I divide it by the index 2. 2 divided by 2 is 1, so that's going to be a 3y on the outside. So your answer is 3y and then radical 5x. Okay. Take a look at number 6. Everything is perfect here. 16 is perfect. Take that out, you get 4. A squared is perfect. Divided by 2, a to the first. B squared is perfect. Divided by 2, b to the first. Okay, everything's perfect. No radicals are left. All right. All right, let's take a look at number 11. So if someone can put in 32 divided by x squared and tell me what the simplified radical would be for that.
4 rad 2.
4 rad 2. All right. Now I'm going to leave the variables inside. And the only one I can take out is the r squared. Okay, so I'm going to divide 2 divided by 2. That's going to give me r to the first. And then the 2pq stays under the radical. Now, when you go to the next page, there are a couple of different examples where there's a number already on the outside. So everybody take a look at question 17. So 17 already has a number on the outside. So when I take the square root of 64 out, that's a perfect square. What's the square root of 64? 8. So if I take this 8 out, what do you think I'm going to do with these two numbers? Multiply, because this is like multiplication. So what is 8 times negative 6? All right, negative 48. And x squared is also perfect. So what is 2 divided by 2? 1. So that's just x to the first power. Okay. Let's take a look at number 19. So if someone could simplify this on the calculator for me, or you could do it by hand. 9 times 6, that'd be what? 3 rad 6? Is that right?
Oh, yeah.
All right, so if that's 3 rad 6, I'm going to put it up here. I'm going to multiply the 3 on the outside by the negative 6 that's here. So that's going to give me what? So negative 18. And the n has to stay underneath because it's n to the first power. Now, I do want you to know, on your worksheets, you might see something like this. If they take a variable on the outside, and let's say it's to the first power or to the third power, you might see absolute value symbols around it. I'm not going to require that you do that, but you will notice that any odd exponent, you might see absolute value symbols. I'm not going to require that you do that when you take them out, okay? But I just want you to know that you might see it on a worksheet. All right. Yeah, the 6 stays there, guys. I just didn't write it in. Okay? Right, the 6 stays there. Anything that's not perfect stays under the radical. All right, so that's going to be part 1 of today's lesson. Part 2 is going to be adding and subtracting. Okay, so simplifying takes care of what you need to do to break down the radical on the calculator or by hand. Adding and subtracting is pretty easy. So it says up here the directions to add and subtract radicals. The number under the radical, of course, is called the radicand, and in order to add or subtract them, they must be the same. So let's look at our radicands. Are these radicands the same? Yes. So if I have 3 rad 6s and I take 2 rad 6s away, How many rad 6s do I have? I have one rad 6. Now I don't need to write 1. I'll just put rad 6. Because 3 minus 2. You keep the radicand number the same. You only add or subtract the outside numbers. Okay? Only add or subtract the outsides. Now, notice that these have not been simplified yet. Because 20 has a perfect square in it of 4. 45 has a perfect square in it of 9, correct? So either you can do this on your calculator. Okay, I like to do it by hand. So I'm just going to break these down. So this will give me 2 rad 5 plus 3 rad 5. So 2 rad 5, because I took the square root of 4 out. And again, you can get it off the calculator if you like. 2 rad 5 plus 3 rad 5s will give me how many rad 5s? 5 rad 5. Okay. All right, let's take a look at number 3. So I have rad 54. I can break that down to 9 times what? 6. And then I can break 24 down to 6 times 4. And again, if you prefer to get the answer off the calculator, that's an option. I'm going to take the square root of 9 out, which is 3. I'm going to take the square root of 4 out, which is 2, multiplied by the 3 that's there. That's going to give me what? 6. So I have negative 3 rad 6 minus 6 rad 6. That gives me what? Negative 9 rad 6. Okay. Now, you may not have the same radicals all the time. Like if this had been negative 3 rad 6 minus 6 rad 2, you would have left it exactly like that. So you're not going to have, sometimes you're not going to be able to add them together if they don't have the same radicand. I'm going to let you do question number 4, and I'll see what you get in a second. I simplified this to 3 rad 5, multiplied the 3 by the negative 3, it got negative 9 rad 5. Okay, so negative 9 rad 5 minus 3 rad 5 is just simply negative 12 rad 5. All right, so let me just go over one that won't work out perfectly like that. So let's just say we had, and I'll just change this first problem. And let's just say this was minus 2 rad 7. So if that were the case, that would be the answer. 3 rad 6 minus 2 rad 7. Okay? So I want you to know that you're not going to always be able to add the radicands together. And it doesn't matter which one you write first. That's the other thing. All right, one little last part, and then we'll be done. Okay? We're going to do a couple of equations. Okay, so go to the next page. And we've done these equations before, so this is really more of a review. When you have a radical in an equation, how do you undo a radical? You square it. So when I square this, of course, you got to do whatever you do on one side, you have to do on the other. Okay, so 9 squared will give me 81. And then to undo this, because that's all it does, when you square it, you end up with the radicand. That's it. So same thing in number 16. I square this side, square this side. I just end up with what's under the radical. And then you just solve it like you do an equation. Plus 10. So R equals to 14. Okay. Square this side. Square this side. You have 100 equals 25x. Divide by 25. X equals to 4. Okay. Now, when you look at number 18, there's a negative 3 on the outside. So the very first thing you want to do is isolate the radical. That means you got to get rid of that negative 3. So how do I get rid of the times negative 3? Now notice I said times negative 3. So I'm going to do what? Divide. You don't add. Negative 3 is being multiplied by the radical. So I'm going to divide by negative 3, and then I end up with 4n, rad 4n minus 4 equals to a positive 6. Now I'm ready to square both sides. Now my equation becomes 4n minus 4 equals to 36, and you guys could solve it from there. Okay, same thing with number 20. You would need to isolate the variable, the radical, so you would subtract 7. So that's going to give you a 5 here. 5b plus 5, square both sides, and solve from there.